figure shows a swimming pool filled with water. A pump is used to remove water from the pool until the pool is empty. When the pump is running, the rate at which the volume of water in the pool decreases is constant. During the first 2 hours, the pump works slower than usual due to a broken piece. Then the pump stops working. The broken piece is replaced and the pump works at its usual rate until the pool is completely emptied of water. The entire process of emptying the pool takes 6 hours. Which of the following graphs could depict this situation, where time in hours is the independent variable and the volume of water in the pool in gallons is the dependent variable? So we're emptying a pool. The pool is being emptied slowly until piece breaks. Then there is no change in the volume of water until the piece is replaced, and then the pool is being emptied faster than what it was initially. And we need to find which one of these graphs models this situation accurately. And this whole process took 6 hours. So we can do this quick check to make sure that the correct graph goes from some certain amount of volume. It reaches 0 volume, meaning the graph hits the x-axis after 6 hours. So if you look at graph A, we see that at 0 hours, there's some amount of water in the pool, and then it gets emptied at 10 hours. That's incorrect because we're told that this whole process took 6 hours. If you look at B, we go from some volume at 0 to 0 volume at 6 hours, so that's correct. And graph C says we go from some volume at time 0 to 0 volume at 6 hours, so that's correct. And the same for graph D. We go from some volume at time 0 to 0 volume at time 6 hours. So now we can further check between these graphs. So we see that they all show the volume decreasing until it hits a flat point where the piece that was broken is replaced. Then afterwards, the change in the volume should be faster, meaning the graph should be steeper, because we know that steeper graphs, they have a higher rate of change than ones that are closer to horizontal. So let's look at graph B. We see that this graph, this line here shows the decrease in the volume in the beginning. We see this is closer to horizontal, and then the graph gets much steeper after we fix the broken piece after this flat point here. So this could be correct. Let's look at graph C though. We see the volume is going down, then it stops while we are replacing the piece, and then it goes down again. But it seems that the slope, the steepness of this line is about the same as it was up here. That can't be the case because, as we were told in the problem statement, that initially the volume was going down slowly because the pump was working slower than usual during the beginning because of a broken piece. So we can rule out answer choice C. Then if we look at D, we see that the volume is going down, then it stops for a little while the piece is being replaced, and then the graph gets much steeper. So this means that the volume was going down much faster than it was earlier. Now, we see that B and D, they both show the correct changes in the slopes, but the difference is that in B says that the volume was going down in the beginning during the first 2 hours before it had to be replaced, the piece, while graph B says the volume was going down for 4 hours before the piece had to be replaced. But the question said during the first 2 hours, the pump worked slower than usual, and then the pump stopped working because the piece was broken. So that means graph B is incorrect because it says that the volume was going down for 4 hours before the piece broke, and we reached this plateau here where the volume wasn't changing because the piece was being replaced. So B is correct because it tells us that the volume was going down for 2 hours, the pump was working, meaning the volume was being removed, the gallons from the swimming pool, before the piece had to be replaced.